Hi everyone. So last week I introduced to you the basics of semantics and how to create and use truth tables. This week we will be continuing talking about truth tables, and most of the content will be simply giving you additional tips and tricks for how to create and employ truth tables. So this lecture, give me a moment. This lecture will mostly consist in review from last week. We're going to be going over what we saw last week about how to use truth tables to test for sentences whether they have various semantic properties or stand in various semantic relations to other sentences. So in addition to giving you additional tips and tricks this week, also in this lecture and the next lecture, I will be working through some more examples of how to solve the questions um, that will arise in the quiz, in the midterm, etc. for truth tables. So let's get to it. So the two parts of this this lecture, is that first we're going to go over creating truth tables for individual sentences to tell whether that sentence is a tautology, a contradiction, or a contingent sentence. And then the second part is we're going to talk about how to um, create joint truth tables, or truth tables that compare multiple sentences. And this is what we have been doing in determining whether, for instance, an argument is valid or whether a group of sentences are consistent, inconsistent, or contradictories. Um, we also use the joint truth tables for testing whether two sentences are equivalent. So let's talk about individual truth tables. So here is a review of the relevant semantic notions which we will create individual truth tables for. First, we have logical truth, or tautology, as we've been calling it. And for sentence phi to be a logical truth or a tautology is for every valuation to make that sentence true, which is to say that for every row of the truth table, it has T under its main connective. For a contradiction or logical falsehood, that means that every valuation makes the sentence false. So that means that on every row of the truth table, there is an F under the main connective of the sentence. And for a contingent sentence, that is just a sentence which is neither a logical truth nor a logical falsehood, which is to say that there is at least one valuation, or at least one row, on which the sentence phi has a T under its main connective, and at least one valuation or row on which phi has an F under its main connective. So this was the method, the six-step method, which I went over last week when I introduced to you how to create truth tables. Now there's a lot of words here, and it's a somewhat complex method, but I'll just very briefly go over the main aspects of it. So the first thing you have to do is you have to figure out how many rows will be in the table. And that is to say, how many possible combinations of truth values are there for the atomic sentences that occur in the sentence phi, which you're creating a truth table for. The answer is that where n is a number of atomic sentences, there will be 2 to the power of n rows. So for instance, if there is one atomic sentence, for instance, consider the sentence P or not P, there's just one atomic sentence there, P. So the truth table for a sentence with one atomic sentence will have 2 rows. The row in which the atomic sentence is assigned true, and the row in which it's assigned false. Now, if there are 2 atomic sentences, then there will be 2 to the power of 2, which is 4 rows. If there's 3 atomic sentences, there will be 8 rows. Then, in addition to knowing the number of rows, to actually construct the columns of the truth table, the first thing you do is you list the atomic sentences on the left-hand side on their own columns, and then in the rightmost column, you'll write out the entire sentence phi. And then what you do, so that kind of encompasses steps 2 to 4. And then in 5, what you do is you write out throughout the rows all the possible combinations of truth values for the atomic sentences. So what you do is you start with the rightmost atomic sentence and fill out the number of rows by alternating between T and F. Then you move one to the left and do 2 T's and 2 F's all the way to the bottom. And then if there's more, you'll do 4 T's and 4 F's all the way to the bottom. And then once you have done that step 6, or the first part of step 6, when you've created the columns and all of the rows, and then all the possible combinations of truth values on each row for the atomic sentences, what you do for the rest of the method is you simply use your knowledge of the meaning of the connectives in the sentence phi to show how on each row, how the assignment of truth values to the atomic sentences builds up to give you truth value for the entire sentence. So that, in brief, is a method. And this is the method that we use to construct all truth tables. And so for individual sentences, we simply apply this method to the sentence phi. And for joint truth tables, as we've seen for testing, for instance, for validity, all we do is we use the same method, but we add additional main columns for the additional formulas. So today, we're going to be talking about cases of both individual truth tables and joint ones where we have more main columns. So here is an example. So consider the sentence A, if and only if, B and A. Now about this sentence, we can ask, is this sentence a tautology, i.e. a logical truth, a contradiction, i.e. a logical falsehood, or is it contingent? Now here I have constructed the truth table for this sentence. So the main columns correspond to the individual atomic sentence letters A and B, and then we write out the entire sentence. And the truth value for the entire sentence will be the column underneath the main connective. Then what we have on the left-hand side is we have all the possible combinations of truth values for A and B, and that can be constructed by starting with B and alternating between true and false 4 times, and then moving over and then doing A, where you do 2 truths and 2 falsehoods. Then once you have that, you just copy the assignment to the atomic sentences to underneath the atomic sentences on each row. And then once you have done that, you can then build up the rest of the truth values by knowing, for instance, when a conjunction is true or when a biconditional is true. Then once we've done that, we can look at the column underneath the main connective for the sentence, and then we can look at the distribution of T's and F's. And if there's only T's under the main connective, then it's a tautology. If there are only false or only F's under the main connective, then it's a contradiction. But if there are some T's and some F's, depending on the row, under the main connective, then this sentence is contingent. And so we see by looking at this truth table, we can establish that this sentence is contingent because there are some rows on which it's true, and there's some rows on which it's false. So the case in which it's false, for instance, is when A is true and B is false. So intuitively, when A is true and B is false, this entire sentence is false because a biconditional requires that both sides of the biconditional have the same truth value. So if A is true, then this side is true. But if B is false, then even if A is true, the conjunction of B and A is false. So if B is false, this entire side is false, and that means then that the entire biconditional, each side has different truth values. Therefore, it's possible for this biconditional to be false, specifically in the case where A is true and B is false. And so that's how we know that this is a contingent statement, and the construction and inspection of this truth table shows us that. So here are some example sentences which you can use to practice by constructing your own truth tables for them, and then looking at those truth tables to determine whether for each sentence it is a tautology, i.e. logically true, a contradiction, i.e. logically false, or a contingent sentence. Now, right now, I will construct a truth table to determine this for this third sentence here. Here we have, in the third sentence, we have a conjunction with the first conjunct being the conditional if S then R, and the second conjunct being a conjunction itself, S and not R. So let's switch to the other screen so that I can build a truth table. So the sentence again is, if S then R and S and not R. So that entire sentence is our rightmost column. And then the first two columns, we have S and R. So now, once we've constructed the truth table, we have to fill out the rows corresponding to each possible combination of truth values for the atomic sentences S and R. So because there are two atomic sentences, we know that there will be 4 rows because 2 to the power of 2 is 4. Now, to fill out those rows in the proper way, we start with the rightmost atomic sentence R, and we go 4 times, alternating between true and false. Then we move over to the left and go down for 4 rows where we do 2 truth and then 2 false. And now we've written out all the possible combinations. And now all that's left is to fill out these atomic sentences with their truth values and then show how they percolate up. So in the reading for today, which talked about some shortcuts, one thing is that you don't have to always explicitly copy over the truth values and from the one under S here to the S here. So what you can do is you can just remember what S and R is on each of these rows, and then just write out what the connectives get, or the more complex sentences get. So here on this first row, if we remember that S and R are both true, we know that this conditional will be true, because the only case in which a conditional is false is when the antecedent is true and the consequent is false, but here both the antecedent and the consequent are true. Then we know that not R will be false. And then we know since one of the conjuncts is false, we know the entire conjunction is false. And then again, the main connective of this entire sentence is a conjunction. And in order to determine its truth value on a row, we have to compare the truth value for the complex conjuncts. So we have to compare the truth value we have under the conditional here and under the conjunction here. And because one of the conjuncts, this one is false, the entire thing is false. So we know so far that this is not a tautology because we know so far that there exists one row on which it is false. But we still don't know whether, for instance, it's a contradiction or whether there is another row in which it's true. So we have to fill out the rest of the rows. Now in this case, we know that this conditional will be false because, as I just said, the meaning of conditional, the conditional is false when the antecedent, the first part is true and the consequent is false, and that is exactly what S and R are on this row. And then we know, because this is one of the conjuncts of the main conjunct and it's false, we know that's enough for the entire conjunction to be false. So we don't even have to look at this one on this row. Now here, this is not a case, this third row is not a case where the conditional is false, So we know it's true. So now we have to look at whether this the second conjunct, this conjunction here, we have to look at whether it's true or false to see whether the overall conjunction is true or false. So we have that S is false in this row, which means that we know that this conjunction will be false, which means the overall conjunction will also be false. Now both of them are false on this final row, but that's still a case in which the conjunction is true. The conditional is true. But now if we look here, we know S is false, which means we know this conjunction here will be false, and then we know again that the overall conjunction will be false. So what we see now is that on every row, on every possible valuation or combination of truth values for the atomic sentences, this entire sentence, if S and R and S and not R, is false. So we know this sentence is a contradiction. And intuitively, the reason why, which we can see without constructing the truth table, is that the meaning of the conditional, the only case in which the conditional is false is when the antecedent is true and the consequent false. So what we're doing with this entire sentence is we're conjoining a conditional with a specification of the case in which this has to be false. So we're saying if S and R is true, and it's true that S is true and R is false, but the case in which S is true and R is false is exactly the one and only case in which if S and R is true. That the case in which S is true and R is false is the one and only case in which if S and R is false. And that's why this entire conjunction is a logical falsehood. So what you can do is you can construct similar truth tables for the rest of these sentences as practice. And here's a couple even harder sentences which you can use to test your skills to the full extent. So I'll conclude this first part of this lecture by making the following observation. Consider this sentence here. I'm not going to bother trying to read it because it will be a mouthful and very long to read. But what you should note about this sentence is that there are 4 atomic sentences. There's F, E, G, and H. And so because there are 4 atomic sentences, that means that the number of rows, or the number of possible combinations of all truth values for these 4 will be 2 to the power of 4, which is 16. So that means to construct a truth table for this sentence will take a lot of rows and will be a very big truth table. So I'm not going to ask you to construct complete truth tables for more than 8 rows, so for more than 3 atomic sentences. But the thing is, we'll still have questions involving sentences with more than 3 atomic sentences. So that means that next lecture, we'll develop a method for dealing with sentences whose truth tables would be impractical to construct, following the method from last week, and then that we've just been talking about, this method here, where you construct the complete truth table. So once you master how to construct complete truth tables for sentences like this, there is a further method of short truth tables or partial truth tables, which I'll be talking about next lecture, which we can test for sentences like this with many atomic sentences without having to spend the time and the space on our page creating giant truth tables. But what you always have to remember, whether you're creating full truth tables or short ones following the method from next lecture, no matter what, you have to know first the definitions of the relevant semantic notions. So you have to know, for instance, what it means for a sentence to be a tautology or a contradiction, etc. So you have to know what the definitions of the semantic notions you're being asked about and how they relate to truth tables. And second, you have to know the meanings of the connectives. You have to be able to fill out a truth table by first being given the assignments of truth values to the atomic sentences on a row, and then you have to be able to fill out the truth values of the complex parts of the sentence on the basis of those atomic meanings, given the meanings of the connectives. Okay, so in the next part of this lecture, I'm going to talk about joined truth tables.